Now we start recording, and we will record our next exercise, and the exercise is 3. Oh, it's a little bit small. 3.6, and it's pressure forces on a dam. So imagine you have a dam. Yeah, here is a dam wall. Here's the ground of the water. Here the water. I made the blue. And the question is, now we want to build up this dam, and we want to build it with bricks, now with some bars, and we should have bars, and on every bar there should be the same force. So this means the bars must be, painting is not so nice. Here's our dam wall. And we now want to take the bricks, and here should be the smallest bar, should be bigger, this should be the same. So okay, and how do you build this kind of geometry? If we have here, if we look from above, and we will okay. So, and the height of the water should be 10 meters. And now the question is, how can we change the height of every dam bar? To get the everywhere the constant forces, everywhere the same forces. Yeah, you want to have the same forces on every beam. So force on beam 1 should be force on beam 2 should be force on beam 3. So the total force is 3 times all the single forces. Okay. So now we calculate the total force. How can we calculate the total force? We need the total area is 120 square meter, and the force can be calculated by density times gravity times it's not what I wanted, times we need let's say times 981 times 5 times 120 is kilonewton. Okay, that is the total force. I think this was not so really easy. And now we can calculate all the single forces. So all the single forces are, let's write it here. Maybe here. Okay, this should be the force on every beam. Okay, but now the question is, how high is the beam? Yeah, and that's now second part of our exercise. Let's calculate the first part of it. We have force 1 is density times gravity times height 1 times area 1. And you know we need the height for the middle point here, and from here. And then we have F1 can be calculated by 1000 meter. And okay, that's the first height here. The first height is 5.77 meters. So now we have to do the same for the second height, for this value here. I delete everything again, and it's the same calculation. So I repeat it for you. H2, you need at first, you need to have force 2 is again Rho G HS2 times A2, and this should be again 1,962 Newton, or 1962 kilonewton. And for this I again need the middle point HS1, and now HS1 has the following formula: H1, so this deep, plus H2 half, plus this amount. Okay, and then I get with the old result so how big is the area here? The area here, we can make the same assumption. We say A2 is H2 times B. B again is the width of the dam or the river. And then we get our formula. Okay, and I wipe a bit some parts now of this board. I wipe it away because you can scroll back with the video later, or you can make a screenshot. And I go on. F2 is 6, 7, 9, 2 plus 5, 8, 8, 6, 0, 2 square should be our 19 kilonewton. And now we have a quadratic formula. We have to solve it, and I bring it to the following formulation: square plus zero. And now we can solve it by the midnight formula, by the PQ formula. And then we get the following. And you all know from your mathematical lectures we will have two different results now, but you will see one result will not make sense. And we will get a height of 2.39 meters. So we only take the positive result. Yeah? Here this negative result will not make any sense. We have a negative. So the negative solution is not senseful. So we only take the positive solution. Yeah? You know this from mathematics. And now we are finished with height 2. We can write it down here. And now is a question for all of you: how can we calculate the height of the beam number 3? Now you should give me all your fingers up. Hello guys, are you still awake? Hello guys, please give me a thumb up if you're still awake, if you still follow the lectures. One last question for this lecture. Yes, Miss Gerhard, you have been the first. Miss Luxemburger, of course. Miss Seiler, perfect. You know it. That's not difficult anymore. H3 is H minus H1 minus H2. And we got 10 meters minus 7 minus 2.39, and we get 1.84 meters. Okay, so I think that's a good solution, perfect solution. I think we're over, and I think the time is also over. I quit the video.